All right, we're going to talk about CPCTC, and actually, I did put this in your packet. I didn't think I did, but if you go to the second to last page, I put the notes in there. So CPCTC stands for congruent. Oh, not congruent. How about corresponding? Corresponding parts of congruent triangles are congruent. So pretty much we're saying if we prove that two triangles are congruent, then any other part we didn't already say was congruent is congruent. So when asked to prove that parts are congruent, so when I say parts, angles or sides, we first have to prove that the triangles are congruent. So how we know when we're using CPCTC is if we look at our proof, and this proof is not proving the triangles are congruent, we're proving that two angles are congruent. So anytime we're proving that angles or sides are congruent, we're going to have to prove the triangles congruent first, then use CPCTC as our end result. So the cool thing is we structure this the same. So we put our givens, if I can get the right pen here. So we start with our given AB is congruent to AD, and that's given. So AB congruent to AD given. And then we have another one, BC is congruent to DC, also given. And we mark that. Okay. Now, before we can do anything else, we still need to have three things marked. We're out of givens, but we do have reflexive here. So the reflexive property applies, and we can say AC is congruent to AC, okay, by the reflexive. So now that we have three things marked, we can prove the triangles are congruent. So I can say triangle ABC is congruent to triangle ADC by side, side, side. And my proof here is what I end with. Angle BCA is congruent to angle DCA. And my reason is just CPCTC. So all I'm doing is adding one piece, okay? And instead of this being last, CPCTC is last, and we can prove that an angle or a side is congruent, okay? All right, so here we go. Number 2, we're going to start with our given. So PS is congruent to QR, given. And you know, anytime we say things are parallel, we get out our highlighter, and we're going to say, so PS is congruent to QR, and then we find our transversal. This makes a Z, so we're going to have alternate interior angles. So here we go. Those are alternate interior. So immediately after saying something parallel, we should say angles are congruent. So we can say angle PSQ is congruent to angle RQS, and that's by AIA. Okay, because we said parallel, we can say AIA. Okay, now we can do our other given. Angle QPS is congruent to angle SRQ. So QPS, SRQ. Okay, so we have two things marked. We have no more givens, but we do have reflexive property. So we can say SQ is congruent to SQ by reflexive. And then, now that we have three things marked, we can look, angle, angle, side. So we know the triangles are congruent. Triangle PSQ is congruent to triangle RQS by angle, angle, side. Now that we proved the triangles are congruent, they want us to say that these two sides are congruent. And these two sides are congruent by CPCTC. All right. So this also works for flowcharts. Okay. So anytime we do a flowchart, remember we have our three boxes. So one. Oh, I think I have like a little tool I can do these with. So let's see if I can make my box. Oh, look at that. I can make boxes. So we're going to do our three boxes. So go ahead and draw your three boxes. Okay, so we got our three boxes. Now, we also have a box to the right, like normal, but not only that, we have to add our CPCTC box. And our CPCTC box just goes right here, okay? So nothing really changes. So our first given is that x is the midpoint of WY and VZ. So remember, we split that up. So x is the midpoint, let's do first, of WY. Okay, so that goes out here. So if x is the midpoint of WY, we highlight WY, and then it cuts it into two congruent parts. So then we can say WX is congruent to XY. And that reason, oh, I forgot to write given here. And this reason is by definition of a midpoint. And then they also told us X is the midpoint of VZ. Okay, and so given, and we can use highlighter again. Here's VZ. Midpoint cuts it into two congruent parts. So we can say Vx is congruent to Xz. And that's also by the definition of a midpoint. Okay. The last thing that we can assume, because we're out of givens, is that we have vertical angles. So we can say angle WXV is congruent to angle ZXY. And so that's by vertical angles. So now we can say the triangles are congruent. So triangle WXV is congruent to triangle ZXY. And that's going to be by side angle side. And then now we can do our proof. Angle XWV is congruent to angle XYZ by CPCTC. Alright, so number 4. So again, we always still do our stack of 3. And then we always know it's going to go to one box. And then because this is talking about a sides congruent, we have to use CPCTC. Alright, so here we go. First given is JM bisects KJL. Well, that isn't a congruent statement, so JM bisects angle KJL given. So if we highlight JKL, okay, or KJL, sorry. Bisects means cut into two congruent parts. So we mark the angles that it cuts in half, okay? So that we can say angle KJM is congruent to angle LJM, and that's by definition of an angle bisector. And then we still have another given, so angle JMK is congruent to angle JML. That's given. So JMK, JML, so those angles are congruent. And then we can say JM is congruent to itself by the reflexive property. We have 3 things marked, and it's going to be angle, side angle, so we can say triangle JMK is congruent to triangle JML. But we're not done because that's not our proof. Our proof is that JK is congruent to JL, and that's going to be by CPCTC. Alright? Alright, last one here. So we're going to do our stack of 3. And then alright. So BC is parallel to EF. That has to go out here. And we highlight, so BC is parallel to EF, and we find our transversal, okay? And so that's congruent, and that's congruent. And then we can say angle CBD is congruent to angle EFD, and that's by AIA. All right. They also told us that D is the midpoint of BF. So I'm going to highlight BF in a different color. So here's BF. And if it's the midpoint, then it cuts these two in half. Let's zoom in. Cuts this, okay, in half. So BD is congruent to DF. I forgot to put it out here. So I'll write my given. I'm struggling, working backwards. Okay, D is the midpoint of BF. So it's given. Definition of a midpoint. Okay. Now we need one more thing, and if we look, we have vertical angles, so I'll mark that in blue. So we can say BDC is congruent to angle FDE. Okay, vertical angles. Now that we have three things marked, we can say the triangles are congruent. So triangle BDC is congruent to triangle FDE, and that's going to be by angle side angle. And then we end with our proof that ED is congruent to CD by CPCTC. Okay, so the only thing that we added is that our new proof is a side or an angle, and then we put CPCTC. So that's it.